Hello there. Welcome to an edition of JUCE Snippets, where you've got a bunch of utility classes and components that you can just pick up and use and reuse within your projects. The first one today we're looking at is text scrolling, or text marquee, as they call it in the web world. You might have noticed this kind of labels when you're developing applications in JUCE, especially where the text within the label is too long to be held within the label bounds itself, and you get the ellipses at the end saying that there's more text further ahead. This is kind of notorious, especially when there's user input involved, like file names and preset names and whatnot. And users can be gits, they can put in unprecedentedly long names. So you've got to try and account for that. One way you can do it is to make it scrollable on hover, something like this maybe. So you can see that the scroll is kind of smooth. It starts off gently and it reads the rest of the text. And as soon as you move away from it, it goes back to the start. Another strategy perhaps would be to just keep rotating the text, keep scrolling the text continuously. Well, in this particular video, we'll be talking about the scroll and hover strategy. And basically, once you've got that down, you can pretty much utilize the same strategy for any other use case. So let's dig into the code and see how it's done. So I've got a new file here. It's called ScrollableLabel, and we'll create a new class called ScollableLabel. And this one is just basically going to inherit from the JUCE Label class. Pretty straightforward. There's nothing to it, but let's just see what it's like to just display the label as is with something with long text. In the main component, I'm gonna just create an instance of ScrollableLabel. And within the CPP file, let's just add this to the main component. Add and make visible of this particular component. Set some text in it. It's also asking if I want to send a notification, so no, I don't really want to send any notification of the text change. I'm going to set its font to, let's say, about 20. Once we add the component, it's just a matter of just setting its bounds so that it's displayed. I'm going to put a constant bound of, let's say, 300 pixels wide, 40 pixels height in height. And I'm going to center this entire label within the center of the window itself. So this will make sure that you have a 300 cross 40 pixel wide label in the middle of the main component. Let's run it and see what it looks like. Alright, so it's kind of squashed the text as well, and can't really see where the boundaries of it are. So why not just put a background color first, to sort of distinguish where the boundaries of the label are. Right, so I'm going to get the look and feel from the label class, and I'm going to set a particular color. This one's going to be the background color ID from the label, from within the label class. I'm going to set it as some color, right? So I'm going to say dark, let's say gray. Let's give that a roll. Alright, cool. So we actually see the boundary of the label itself, and now we can actually implement the scrollability of the text within the label. So what do we need to do? So let's go back into the ScrollableLabel class, and let's implement some functionality. The first thing that we want to do is listen to the mouse inputs. So when a mouse goes over a component, there's a callback function called mouse enter that you can override. You'll receive events within it when a mouse hovers over a component. Similarly, there's a callback for mouse exit, where you can get notified when a mouse exits or leaves the component, leaves the label. So within the mouse enter, whenever a mouse enters this particular label, we need to firstly decide if the text is longer than the width of the component. If is text longer than the width? If it's not, then we don't really need to do anything, right? So if the text is contained within the bounds of the label itself, we don't really need to do anything. It's just a plain old label. But if it is, then we need to do something else. Where can we get to know if the text is longer than the width? So there are a couple of places that come to mind. One would be the resized method, where you'll have like the bounds established already. And then in the paint method as well, we'll still get the bounds of the component. Let's override the paint method, because we'll be using the paint method soon anyway. Within the paint method, what are the bounds of the label? You can get the bounds of the label by saying get local bounds. But we can do better. We know that the text that appears within the label is actually constrained, which is reduced in size a little. So we need that area instead of the entire area. So we've got something called get border size, which will give you like the borders of the text area. And you can subtract that from the local bounds, and that will give you the label text area. Next, we want to try and determine what the width of the text would be if there were no restrictions, let's say. Let's think about a scenario where there is no restriction. You've got like a very lengthy bit of text. How much width would that take up? So we want to try and get the optimum width that a label should be to accommodate the entire text. This will obviously be dependent on the font. So there's a handy little convenience method within the font class. So what we do is say get font, and that'll give us the font that's set for this particular label. We have a method within the font class called get string width. It's pretty handy. It says it returns the total width of the string as it would be drawn using this font. Yeah, so it'll give us exactly the width in pixels based on a given font. This accepts a text value. I'm just going to pass it the text that's associated with this label. Now we want to calculate if this optimum text width is greater than the label text area itself. Now we can capture this particular Boolean value. So I'm going to create a member variable called is text longer than width. I'm going to initially set it to false. And then I assign this value within the paint method here. So basically, we get to know if the particular text that's associated with this label is greater than the width of the label itself. If it is, then we need to call some sort of timer on a regular basis to sort of to animate this component so that the text actually moves, right? So for any animations or anything that just moves over time, I suppose, you can always make use of the timer class. So let's inherit from the timer class and implement the pure virtual function, which is timer callback. We don't want to start the timer immediately as soon as the mouse enters. We will want to wait for the mouse to hover around a little bit before we reveal the entirety of the text. Right, so one thing that you can do is basically start the timer after a particular delay. So you've got a static method within the timer class called call after delay. This will basically just invoke a lambda, like an anonymous function, on the message thread, and then it basically accepts what's the delay in milliseconds, and then just a callback function that will be executed after that delay. I'm gonna create a member variable. Currently, it's just going to be a constant value of, let's say, about 500 milliseconds. But then obviously we can make that configurable and put like a getter or setter for that particular value. Once you do that, then you basically need to provide a function callback. And this is going to be very simple, right? So we just need to start the timer after this delay. So I'm going to start the timer. I'm going to start timer HZ instead and say 24. This will mean that the timer basically runs at every 24 frames a second, basically. There is a bit of a problem using this entire method of call after delay. The problem is that, like, let's say this particular label component goes out of scope or gets deleted after the call after delay method is executed. So the problem is that the anonymous function will still contain start timer HZ of a deleted ScrollableLabel instance. So there is a chance that this thing could break, especially if components go out of scope or get deleted. But in our particular case, it doesn't, so it's pretty safe to call this. To make sure, to make it bomb-proof, what you can do is implement a multi-timer instead of just a timer, and you have two different timers now. One is a delay timer, or let's say 500 milliseconds. The only purpose of the delay timer would be to stop itself and start the actual animation timer, right? So that's one way to go about it. But for now, let's just keep things simple and just go with this approach. Right, so you've started the timer now. And as soon as you start hovering over the component after about, say, 500 milliseconds, the timer callback is called back. So within that time, you could have moved off the component, or you could move later down the road as well. So you want to see if the mouse is still over the component at this point in time. So if mouse is not over the component, then we stop the timer. We don't really need to run this timer anymore. And then just return out of this method. But if the mouse is still on it, then we need to start the animation process itself. So how do we actually perform the animation of the text scrolling? So let's just talk about this for a second. One of the ways that you can do this, and the way that we're going to do it here, is to basically just write the entire text out and then just translate this or move this on the x-axis so that more of the text is revealed within the label component as the text slides across the x-axis. So we need to keep track of some sort of progress indication. And this progress indicator will just basically be a normalized floating point value from 0 to 1, let's say. So 0 indicates that the animation progress is at 0%. 1 indicates that it's fully animated and it's revealed the rest of the text, whatever is left. Within the timer callback function, and remember this timer callback will be called every 24 times a second, basically. So within that time, we slowly start incrementing the animation progress variable. So we're going to increment it with, like, let's say 0.05. So over course, this thing will go from 0 up to 1 and so on. But then we want to end it at 1. So let's put a condition here saying if mouse is not over, or if the animation progress is greater than or equal to 1, then we don't really need to do anything else here. So we just stop the timer. We'll call the repaint method now so that the label can paint itself, and the animation progress will obviously be used within the paint method to determine which area of the text to paint. But we'll get to that soon enough. Right, so the mouse exit method is still unimplemented. So let's just implement that quickly. Again, we want to try and check if the text is longer than the width. If it isn't, then we don't really need to do anything. If it is, then we need to stop the timer. And then we'll reset the animation progress back to 0. Well, come to think of it, I don't think we'd need the stop timer here, because if the mouse isn't over it anymore, the timer callback will stop its own timer. So we don't really need to worry about stopping the timer in mouse exit. But one thing we do need to do is call the repaint here, because we're explicitly setting the animation progress to 0. So we want to repaint the component to sort of update its position now. All right, so now within the paint method, we do the actual drawing bit of it. Before anything else, let's just create like a background and then actually write the text out. I'm gonna say set color. I'm gonna find the color of the background color ID. So I'm doing this because I'm honoring the actual enums for the colors. So you can basically very easily customize this label from outside this component, right? So none of the color codes or whatnot is embedded within this class itself. I'm going to fill a rounded rectangle of the entire bounce. I'm going to set the corner size to, let's say, 4 pixels. Next, to actually draw the text, so I'm going to set the color. I'm going to find the color, and I'm going to this time it's going to be the text color ID. I'm going to set the font that we're going to use, and I can just get the font that's assigned to this particular label. And finally, we're going to draw the text. So we're going to use the draw fitted text method. And this accepts the text itself. I'm just going to get the text from the label. Now this is where we need to figure out the actual bounce that we need to draw. And this bounce would have to move over time. But let's just call it text bounce for now. And we'll fill this up later. Next, we need to set the justification. I'm going to honor the justification of the label. The number of lines should be 1. And the horizontal scaling, I'm going to set this to 1 because I don't really want it to be squashed. I don't want any horizontal scaling on it. And the text bounce, we need to set some default for it. And the best default to set here would be the label text area itself, right? If the text is not longer than the width, if the text string itself is short, then this is perfectly fine. The text bounce will be equal to the label text area itself, so it will be well contained within it. But if it is not, if text is longer than the width, and let's also say if the animation progress is more than 0. So if it's 0, we know that it's not really animating, it's just a text field with like the ellipses. If it is more than 0, then it's actually animating, and we need to actually figure out the customized text bounce. Let's create a rectangle for the text bounce. And this is mostly going to be the label text area itself, but like larger to accommodate the entire width of the text. We'll get the X point from the label text area. Now what we need to figure out is the distance that this text bounce need to move in pixels as the animation progresses. Well, let's just figure out what the difference between the optimum text width and the label text area is. And let's just call this X translation. Basically, we need to move this many pixels as the animation progresses. We've got the X point from the label text area. So I'm going to say label text area, get X minus the X translation amount times the animation progress. I'm going to cast this out to int because this is an integer rectangle. The Y point will be the label text area's Y point. The width will change, right? The width will be the actual optimum text width. The text bounce is going to be as large as the text should be, but the height can remain the same. Let's just see what we've done so far and just build the application and see what we get. Right, so we get this text box, and lo and behold, it's animating. It's showing the entire thing. As soon as we move the cursor away from it, it stops the animation and goes back to its original state. But as you can see, the sort of scroll wipe is sort of linear. Linear motion is really not all that natural. So we want to try and do some easing. We want to try and ease it at the start and then ease it as it ends. So what we need is an easing function that we can implement to make this linear motion feel a little more natural, let's say. Let's go and figure out an easing function. So I'm going to go to the handy Desmos calculator. Over here, we'll see what we already have. So what we have is y equal to x. Basically, it's a linear function. It's a straight line through the axis. And as you can see, you've got a linear straight line going from 0 to 1. And this is how the animation is taking place at the moment. But what we want to do is implement some sort of easing so that it starts off gently, increases in speed, and then slows down, like an ease in and ease out. Well, you can obviously just check it out online to see if you can find some functions that you can just copy from the internet for ease in and ease out. I'm sure there are plenty of them and, you know, efficient in plenty of ways. But let's just roll with our own. The smoothing function sort of looks like a sinusoid of sort. So a sinusoid is always a good place to start. I'm going to use the cos function here. And cos of x gives us this particular curve. The cos function goes from 0 to 2 pi radian to complete the full wavelength. But what we need is just half the wavelength. So it goes from 0 to pi. So let's multiply x with pi, and that will give us half of the wavelength of the cos function now goes from 0 to 1. Now the wave function right now is oscillating from 1 to -1. We need to scale it and translate it up on the y-axis to go from 1 to 0, right? A simple way to do it is just multiply by 0.5 and just add 0.5 to it. This is kind of the shape that we were expecting, but the phase isn't right. So let's just you know, move the phase around a little. Let's subtract pi radian from this, and voila, we've got a smoothing function. Not the best smoothing function, but yeah, it'll do its job, I suppose. You can try and experiment with this by, let's say, just powering the cos function itself to get pretty weird shapes. Definitely certain things that you can experiment. But the base function that we're going to use is this. It's cos of pi x minus pi times 0.5 plus 0.5. Basically, this is going to be our smoothing function. We're going to map the linear value, which goes from 0 to 1, with this particular smoothing function so that it goes slow at first, speeds up in the middle, and then slows down at the end. So the little delta that we are adding to the animation progress is the linear addition. But what we need is to actually keep hold of another variable here. This is kind of evident because, you know, you have two curves here. One is the linear curve, and the other one is the smooth curve. So we need to hold the state of both of them. So for the linear curve, we'll call this phase as like a phase pointer. And set this to 0 as well initially. And wherever we used animation progress, we can try and use phase instead. And we'll just use the animation progress when we're actually drawing it. The phase again would be the linear curve. And now animation progress will be the mapped cosine function. I'm going to say the cos f function from within the standard library. I'm going to supply the phase, which is going to be our x, times pi. Pi is actually defined within the JUCE math constants. But that's a bit of a mouthful. A local variable for pi. Obviously, you can try and optimize this for better performance. But hey, we're running beefy machines here, so performance. Who cares about performance, right? Let's complete this function. So this is basically phase times pi minus pi. Multiply that by 0.5 and then add 0.5. So we're scaling and translating. All we're doing now is we're incrementing the phase, which is going to be our linear value. We're incrementing the linear value. We're seeing what the smooth value is for that particular linear value. We can see that the paint method actually doesn't really need to change at all. All we have done is change the mapping function from going from linear to sort of smoothed. But the paint method doesn't really care what the mapping function is or what the value is. As long as it's from 0 to 1, however it's mapped, it'll do its thing. Let's just run this and see what we get. There you go. So it's got this more of a natural swing to it, but it is a bit too fast for my liking. So I'm going to try and slow the animation down. The value that we can change to slow this down is the phase increment, the delta. So if I try to decrease the delta, it means that more iterations of the timer callback is needed to achieve the phase of 1. If you decrease the delta, the animation is slowed down. So again, you can You can calculate this based on the timer duration, and you can put a millisecond or a second counter to it and expose this as a method that you can actually twiddle and tweak for let the users maybe have control over the speed of the animation. But for now, this is going to be 0.02. It's just some scalar value. So let's see how that looks now. Yeah, much better. Slower. But at least you can actually read what the label says now. Well, there you go. A simple text scrolling label that you can basically reuse within any project, really. You just take this header file and use it anywhere. This is just one strategy of animation, and this is the way and approach I chose here. But I'm sure if you put your heads together and sort of think about it, there are plenty of other ways to do it as well. So if you've got a better way, definitely let me know in the comments. I'm all ears, and I'd love to know how people solve simple problems in more unique and innovative ways. That's it for today. All the code is in GitHub in the link below. You can check it out there. And if you've stuck around, thanks for watching. I know I've been away for a while, but I do hope I can, spend a little more time on making these YouTube videos. I do enjoy the process of making them. It's just that I don't really have a lot of time at the moment. Life, man, I tell you. Well, thank you. And please do subscribe. See you later.